Where was I? How does var infer the type? Okay, so we just sort of hand-waved over that, and I said, okay, the compiler figures out the type for you. You have to have enough information there for the compiler to figure it out. And where does that information come from? It comes from the right-hand side of the declaration. So here, in the right-hand side being when you declare a variable, it's not required, but when you declare a variable in Java, it's optional whether you initialize it. And you can initialize it by providing an initializer on the right-hand side of an equal sign. So in order to use var, you must provide an initializer. So I'll just go through some quick examples here of how this works. So we have a declaration var customer equals new customer. So if we have a customer class and we call its constructor, what's the return type of that constructor? It's an instance of customer. So that's the type that is inferred for that variable. Okay, next line, var name equals Terry. That's a string literal. That has type string, and so that's the type that's inferred. Name is the variable being declared here, so its type is inferred to be string. And in the third line, var numbers equals list of 1, 2, 3. Okay, and I don't know how many of you have moved past Java 8. This is a new set of collection APIs. I'll be talking about this tomorrow in my talk. A new set of collection APIs introduced in JDK 9. And this returns a list of the things that you give it. So a list of 1, 2, 3 returns you a list of integer. And so in this declaration, var numbers equals list of 1, 2, 3. Numbers gets, the type inferred for numbers is list of integer. Okay, that's pretty simple. There are a bunch of cases, though, that don't work. So if you just say var customer and you don't initialize it, there's no information there for the compiler to attempt to infer the type. So we disallow that. There's some other cases. I don't want to go into great detail now, but if you're curious, you can talk to me about that. But basically, we say, you know, if it doesn't have an initializer, can't use var. Var customer equals null. Okay, well, so this is a bit of a subtle issue. What's null? Well, null must be an object of reference type, so maybe, well, actually it's not, though, because it's actually, there's a special type defined in the language spec called the null type, but that's really way too specialized, and in fact, it's not useful. Maybe it should be inferred to be object, but you're probably going to assign something else to it, not an object. So inferring type object isn't really useful. So we basically said, we could figure something out here, but it's not useful. So we are disallowing use of var if the variable is initialized to null. On the last line here, this is an attempt to declare a variable and initialize it to a lambda expression. And so if you've studied lambda expressions at all in Java, the type of a lambda expression is determined by its context. It's what we call the target type. But var does not provide a target type. And so we actually have inference kind of needing to go in both directions. We need to say, what's the type of the lambda expression? Well, look on the declaration side. Well, var is saying, look on the other side. So they're trying to infer some things from each other. And this just doesn't work. So you basically can't use var if you're initializing something to be a lambda expression. You can add a bunch of other stuff in there, like casting and stuff like that. But that's, you can certainly do that, but in general, even if you provide explicit types with for the lambda parameters, there's still more information that needs there that's necessary for type inference. All right, if you've declared a variable using var, can it be reassigned? Answer, yes, but it has to conform to the usual static typing rules of Java. So we've said var name equals Terry. That's a string. Now, later on, we assign name to Dana. That's OK. Dana is a string. Terry is a string. So the name variable has type string, so that assignment works. Now let's try to reassign name to list of Robin and Kim. OK, like I said earlier, list.of gives you a list of things. In this case, it gives you a list of string. And so that's not compatible. You can't assign a list of strings to a string. So that doesn't work. You get a compile time error. So the compiler is checking this for you statically. Again, this is the Java's regular old static typing system. Now let's declare a new variable, nameList. Var nameList equals list of Rob and Kim. Okay, that's a list of string. That works fine. NameList equals new ArrayList. Okay, so that actually works because list.of returns you a list type, and that's the type that's inferred for nameList, list of string. New ArrayList with the diamond operator, that's also a list of string. And so that works. So you can reassign var variables as long as the type is compatible. Again, it's almost exactly as if you had written out the type explicitly yourself instead of writing var. Now, suppose you want a type that cannot be reassigned. Then just say final var. Just like you could say final string name, you could say final var name equals Terry, or Madison in this case. All right, so let me run through a simple example here of showing var in context. We have a method create customer returns customer. So we create a local variable customer whose type is customer, open a buffered reader and assign that to a variable to use within the try with resources, and then we get some purchase orders out of the customer and iterate over the orders using for loop. And so you can start to see there's a lot of redundancy here. So customer equals new customer, buffered reader equals files new buffered reader, purchase order get purchase orders. Okay, so there's lots of redundancy going on between the left and the right hand sides. So those are cases where we can use var to reduce the amount of redundancy. Var customer equals customer, var reader equals files new buffered reader, var order equals, for order in customer.get purchase orders. Makes perfect sense to me. All right, so, hey, pretty good. We about have an hour left. Anybody have any questions? No. So there's a lot more. So I will take questions at the end, but there's a lot more. That was a joke. I'm not ending the presentation yet because, this is the thing. When we introduce this feature, this is something that people have asked for a long time for Java. Can't you get rid of all this redundancy? And so we added this feature, and it's surprising. I think it was a different group of people said, this is a horrible feature. You're going to ruin Java. You're going to turn Java into JavaScript. Oh, only lazy programmers are going to use var. Don't use it. Anybody who uses var is a terrible programmer. It's going to make my code unreadable, and so forth. And that's a problem, right? So somebody posts an article about this new var feature, and I made the mistake. I read the comments. And this is the kind of comments that come in, and it's pretty funny. So on the one hand, it's like when you Java guy is gonna give me this nice a nice feature like var, like all these other languages have, and then so we provide it for them, and they say you guys did it all wrong. This is terrible. But there's a needle to be threaded here. So I want to talk the rest of the talk about is using var using the right style. So I'm going to be talking about benefits and advantages and disadvantages of using var. And so I think this is the real part of the talk. So that was just the intro about what var is. Okay, so why do we add features to the programming language? Because we want to enable people to write better code. And so our claim is that using var in the right way, but using var can result in better code. So you started to see a little bit of that on the examples that I showed earlier. We started reducing the redundancy. It wasn't really terrible code before, but there was a lot of redundancy there. And so var can get rid of, you can use var in places where there's redundant type information, and it reduces the verbosity, reduces clutter. But there's another thing too. It's a little subtle. It's not just about reducing redundancy. When you're declaring a variable, what are the important parts of that? Well, maybe the type, of course, is important because Java is a statically typed system, and you need to think about what type that is. But the type is sometimes not the most important thing. Sometimes the name of the variable is more important. And the name doesn't necessarily tell you what the type is. The name tells you what you're working with. If you choose a good name, it says, oh, I'm working with purchase orders. And maybe the type is named customer purchase order or something like that. Do we necessarily need the whole type? If you just have a variable named order, it's like, oh, of course, I'm working on customer orders. I know exactly what order is. So that lets the name stand out. Or maybe you have two orders, the old order and the new order or something like that. So what var lets you do is get the type out of the way, the explicit type out of the way in the declaration, and let the name come out more prominently. And I have some examples where I think you can see that very vividly. But really what this gets down to is readability. One thing that a lot of people say, and it's not necessarily wrong, but it's a little bit off the point. What they say when they see the var feature is, great, I'm not going to have to do as much typing as in keyboarding. I have fewer characters to type. And then people come back and say, well, I have my IDE do auto-completion and things like that. And so really var is useless because it's really not saving any keystrokes. And maybe that's true, maybe it's not. You can have that discussion. But it's not really about the number of keystrokes. It's really about readability. And so if you have a bunch of code, then sometimes the explicit type tells you very important information. Sometimes the explicit type is not that important. And when it's not that important, use var to get it out of the way. And in fact, sometimes the explicit type is so large that it overwhelms what's going on in the rest of the code. And getting that out of the way is a big benefit to the readability of the code. Okay, should you use var or shouldn't you? One of the criticisms that you'll see in the comments on articles about var is people will write terrible code using var. And I'm sorry to say they will. And I'm also sorry to say that people will write terrible code without using var. So I think the only thing we can say is if somebody's writing terrible code, let's work with that person and teach them to write better code. But that's not an argument not to add the var feature to the programming language, and it's not an argument not to use var in the right places. But there is a point here, which is there's a right time to use var, and there are times when it's not necessary or unhelpful. Okay, so don't use it in those cases. And what we need to do is figure out what those cases are. And it's not that difficult, but it's a matter of understanding all the trade-offs and just developing a style for the proper use of var. What we've done is, this is a precedent that we're trying to start here, is introduce a set of style guidelines for the use of a new language feature at about the same time that we've introduced that language feature. And so in the past, we introduced a language feature and then just let people fight it out. It's like, no. So now, and it's interesting, so I have a confession to make. When this was first proposed internally inside of Oracle, I was opposed to this feature. And my argument was, well, two arguments. One was, it'll enable people to write bad code, which is what I told you was just wrong, but I changed my mind. And the second one was an opportunity cost, which is maybe we should work on something that's better. Now, it turns out it wasn't that difficult to implement, and it's possible to mitigate the bad code argument. And the way to mitigate that is to come out with a style guide that says, here's this new feature, here's the right way to use it. And then when people are trying to adopt this feature into their projects, they can look at the style guide we've written and say, okay, so the people who designed this feature wrote this style guide and said, okay, yes, these are cases where it really helps. And these are cases where actually that's kind of a pitfall, so avoid that. And so I think that will help a long way to get rid of this, people will write bad code argument. All right, so this document is posted on the OpenJDK website. Don't worry about the URL. I will have that at the end, and you'll be able to get that. And so the outline of the style guide is here. There's quite a bit of material in the style guide, 4 principles and 7 guidelines. I'm not going to be able to hit all of them in this talk. I will hit a few of the highlights, though. But I think it's worth going through the principles very quickly. I earlier made a point about readability. That's principle number one. Reading code is more important than writing code. Again, the amount of keyboarding is not at issue here. It's when you revisit the code you wrote 6 months ago, or you're trying to figure out somebody else's code. Is that code readable? Is it easy to understand? Can you grasp what it's trying to do, as opposed to figuring out, oh yes, this is the type of this variable. Code should be clear from local reasoning. And so this is you can kind of see how this informs the design of the language. We said var must be used with an initializer on the right-hand side. It is possible to design a language where the type is inferred even if there's no initializer, but we decided against that because we think that makes it more difficult to read the code. So if you said var name semicolon, and then its type was inferred by how it was used everywhere else, how would you figure out what name actually is? You'd have to hunt around the code a lot, figure out its usages. You have to do the type inference in your head or in your IDE yourself. And that goes against readability. So we said local reasoning. You can look on the right-hand side. Oh, I know what that is because the right-hand side has this type. Code readability shouldn't depend on IDEs. So one of the arguments we often hear is, well, you don't ever need the explicit type because you can always point at a variable in your IDE and it will tell you the type. And most IDEs do have that feature, and that's very nice and that's very useful. But that shouldn't be essential to the readability of the code, because not all code is read in an IDE. Sometimes you're browsing a website and somebody posts a snippet, or you're reading a patch or a diff or something like that. It's not in an IDE. You need to be able to look at the code, use local reasoning, and figure out what's going on in that. And if you need to figure out what the type is, it should be apparent by reading the code there and not pulling it into the IDE. And the final thing is pretty subtle, but basically using explicit types in a type declaration is a trade-off. Various people make some pronouncements like, Java's a statically typed language, the type system is the most important thing. You must have, very absolute statements here, you must have the explicit type because otherwise it's not Java anymore, it's essential, and so forth. And sometimes it is, sometimes it isn't. It depends on what's going on in the code, and it depends on what's going on in the context of that code. Sometimes the explicit type is not the most important thing. All right, so let me move on to run through some examples here. All right, so this is a typical Strawman argument that I see a lot on the internet. And boy, I tell you, you read the internet and it's such a great source of conference talks. So, all right, somebody says, here's why var is a bad idea. My class x equals get something. Now, if I replace that with var, the explicit type is gone. This is unreadable. Don't use var. Well, I guess I'm not using lavalier anymore anyway. Okay. Okay, so as you can tell, that's sarcasm there. Let's look at this declaration. I mean, it's an example. So it uses x. What is that variable name? Well, that's just an example. It has no meaning. What does get something do? What method is that? What return type is it? That doesn't tell us anything either. So if you have my class x equals get something, of course that's terrible code. It's already terrible code regardless of whether you're using var or not. So let's use a slightly more realistic example here. So input stream equals socket.get input stream. Okay, how many of you have written that code? Right? Yeah, everybody, right? Okay, var input stream equals socket.get input stream. All right, now, so in the first line we said input stream 3 times. Have we lost anything by reducing that to 2 times? No. Okay, so here we can see the guidelines start to come into play. So the first guideline is choose variable names that provide useful information. Well, we know that it's an input stream, so okay, that's good. Consider var when the initializer provides sufficient information to the reader. Okay. Get input stream, you're getting an input stream out of a socket. We know exactly what that does. All right, so here's a bigger example. This is a try with resources statement. Let's look at this for a minute. Where are the variable names? All right, so I've highlighted them for you. They're kind of buried in the middle. What's going on here is we have the redundant declarations on the left-hand side and the right-hand side. And so it tends to obscure the variable names a little bit. So actually, as an aside here, notice I'm using 3 separate variables here. We do want 3 variables because these are declared as resources to the try with resources statement. And it provides better robustness in the face of edge case exceptions if the construction of one of these streams were to throw an exception, it would properly close the previous ones. So we do want these 3 variables to be declared here, but the fact that we have to declare the explicit type every time, you know, it's kind of getting in the way. And what happens is the type names are long, we're forced to break lines, and it really kind of loads up a bunch of clutter into the statement. All right, let's replace them with var. Okay, that cleaned it up quite nicely. We haven't lost anything. We know exactly what's going on there, and all the resource variable declarations fit on one line. So I think that's a lot nicer. All right, so here's another one, and it goes to, instead of choice of variable names, it goes to choice of type names. So suppose we have something called a provider, and we say provider equals new provider. Well, what kind of provider is it? Is it a provider of a crypto algorithm? There are a bunch of those in the JDK. Well, in the case that I was talking to one of my colleagues, actually, no, it's not that at all. It's a provider of repository hosting services. And so maybe you really, to distinguish it from other kinds of providers, you really want to provide a very long explicit type name so you know exactly what type of provider it is. But that penalizes users of that type because now they're forced to say, repository hosting provider equals new repository hosting provider. Okay, so now we got a really long type name, and the penalty is, since it's doubled, since it occurs on the left and right-hand side, then that's a disincentive to using long explicit type names. But now that we have var, you don't have to pay that penalty anymore. So you can use a longer name and not have to worry about the doubling because it doesn't necessarily occur on the left-hand side. Okay, so here's a nice one. This is a for loop over the entries of a map. And the map, if you've ever written any library code, you might have to have a generic type with wildcards. And so you get the entries out of the map, and that's a wildcard generic type. And then to iterate over it, you also need a wildcard generic type. And so I see some people squinting at it and frowning. That's really hard to read. And again, where are the variable names? Or actually, it's a for loop, and it's a classic for loop with an initializer, a termination condition, and an increment. Where is that? I mean, it's just a mess of question marks and angle brackets. So I'll highlight that for you. That is the initialization of the loop variable. That whole thing on the first line, iterator, question extends map entry, question extends string, question extends number, is the type of the iterator variable. You can't shorten that. Well, you couldn't shorten that before because just of the way wildcards work. All right, and then the second part is the termination condition of the for loop is iterator.hasNext, and there's no increment in the for loop body. So that's why there's nothing after that semicolon. And so that's pretty hard to parse because it's pretty hard to read because there's a lot of visual clutter from the question mark and angle brackets, and it just turns the header of the for loop into a mess. Let's see what. Oh, and then there's a local variable inside the for loop where we get the next entry. And so again, this has one of these ugly wildcarded generic types. And so that's pretty hard to see. But that's where the increment occurs because that's where we call iterator.next. All right, you think we can improve this by using var? Okay, that cleans it up pretty nicely, doesn't it? That's the time when var really shines. If you have a type, the type is really unnecessary here. You know you're iterating over a map of string to number. And the fact that you have a map entry and an iterator that essentially has a type that's derived from that writing out those explicit types does not buy you anything. So just use var there. All right, quick note about programming to the interface. So this is a subtle bit here. So the guideline is don't worry too much about programming to the interface with local variables. Now, the key there is the qualifier, with local variables. So quite often you write code such as list of string list equals new array list. Okay, so on your left-hand side, we are declaring the type to be the interface, and on the right-hand side, that's the implementation class, array list. Now with var, we're saying var list equals new array list. A couple things going on here. One is, to use the diamond operator, it needs information from the left-hand side declaration. That isn't there. So we actually can't use, well, we shouldn't use the diamond operator here because, so that's a rule. There's another style guideline which I don't think I cover, which talks about var and diamond. But suffice to say that avoid using var and diamond together. So we want to use an explicit type here. But the other thing is that the list variable, instead of having type list of string, it's now array list of string. Is that a problem? Now, it would be a problem. Okay, so I have a code example here. So let's look at this. We have get names that returns a list of string, and then we've initialized the local variable list from an array list. Okay, so list, the local variable, has the type list of string, and we're adding some things to it and so forth, and returning that list. And the return type is list of string. Great. Now let's use var. Okay, the type of list is now array list of string. Is that a problem? Well, you're adding a bunch of things to it in this code, and then you're returning it. It's a local variable, and your methods should be pretty small, so maybe it doesn't matter that much. Now, I'm not saying that programming to the interface is an obsolete concept. It is still a very, very important concept, but it applies to APIs. The return type of this method is still list of string. You don't want to return array list of string here. And in fact, this is the reason we don't allow type inference in method return types. All right, there's another subtle case here where you might want to think a little bit about using var, which is with generic methods. I did mention that little pitfall with diamond and var. There are other things like the generic methods like list.of. So it turns out list.of ABC. That's pretty easy because the arguments are strings, and so clearly it returns you a list of strings. What if you just say list.of, which returns you an empty list? What's the type of that? Well, it turns out that the compiler will infer list of object for you. And that might not be what you want. So in that case, maybe it's better to use an explicit type. So in this case, if you're using generic methods, make sure that there's enough information in the arguments or in the target type to provide the typing information. All right, I'm going to do a quick demo here. Let's see if this works. Okay, I am running Apache NetBeans 9. Quick bit on history. NetBeans has transferred from its netbeans.org into Apache, and they've just released NetBeans version 9. Since the transition to Apache has taken some time, the version numbers are now out of sync. So even though it's NetBeans 9, it actually supports Java 10. So var does work in here. They're working on Java 11, and they're trying to get a release of NetBeans out that supports Java 11 in a few weeks. All right, so I've taken an example here, which is basically a JSON processing tutorial that uses the JSON-P API. And I just pulled this off the web. That's the URL there. And it's basically some pretty simple sample code. It reads some JSON out of a text file, creates a reader, gets the tree of it, and then pulls some information out of it into some data object. And see people taking pictures of it. It's really not that interesting code, but basically it uses a bunch of local variables where we can use var. All right, so where can we use var here? Can we use it in method parameter declaration? No, can't do it. All right, how about here? This is local variable. there's no initializer on it, so we can't actually use var here. So notice that it is this is only assigned inside the try block. But we can use var. We can use var here. We can use var here. Okay, that's not a. Okay, we can use var here. Oh, this is an interesting point here. There's a little hint thing here. Oh, this it's kind of small, but you get a NetBeans has some little hints. You can switch back and forth into using var or using explicit type. So that's kind of nice. All right, JSON array, I can replace that. Now this is interesting. I can replace a string array with var because it's initialized on the right-hand side. Now this is an interesting one. The JSON types, if you look at what's going on with JSON types, JSON object is, I mean, obviously it's an essential type for this API, but it's not telling you any information about what this application is doing because everything is a JSON object. But this is a string array, and that's rather different. So you might want to make the decision to leave that as an explicit type. It's kind of up to you. Okay, JSON value. Actually, there's a bug in NetBeans here. The refactoring doesn't work. Replace var there. Address equals new address. I mean, you see, yeah, I mean, this is sort of toy code. Company equals new company. Address equals new address. So you can clean things up a little bit here. So that's kind of nice. It's removed some redundancy. It hasn't made a huge difference, but if you have big complicated code, you can go through and maybe judiciously replace var, replace explicit types with var. And it's kind of interesting too. I don't know how well this shows up on the screen, but you can start to see some little yellow squigglies here in the import lines because those imports are no longer used because we're not using those type names explicitly. Now, obviously, the types are being used because they're inferred, but the type names are no longer being used. So that, you know, you can hit your cleanup imports and get rid of those excess ones. I mean, that's not a big deal, but if you like to keep your import statements nice and tidy, then that's helpful. Oh, that's right. And then that last thing, if you point at, let's see, what's a good example here? JSON array. Well, if you point at a variable and hold down a shift key, you can kind of see there's a little tooltip there that tells you it's a JSON array. And I mean, as if you couldn't tell by the variable name. But you know, if you have some big complicated code, it's useful. So that feature is there in the IDE, but we've chosen a name here that, you know, doesn't necessarily mean you have to use it. All right, let me switch back to presentation here. All right, okay, so we're pretty close to the end here. Just to summarize, var asks the compiler to infer the type for you of a local variable declaration instead of you having to provide an explicit type. And I think the key thing to remember here is that we're all used to explicit typing in Java, still a statically typed system, it remains a statically typed system, but sometimes declaring the explicit type isn't really that necessary, and in fact it's redundant, in which case consider using var. It can improve readability and clarity of code. Think about those examples I showed. Sometimes the explicit variable declaration will just, or the explicit type in a declaration will just overwhelm everything else. And when you run into cases like that, I think var is very nice. And then I will post the link on to the style guidelines on the next slide. But I'm sure you and your teams will have lots of discussions about should you use var here or not. And of course, I can't tell you what the right decision is for your project, but please read the style guide and think about it and use that information in there to make your decisions about how to use var. All right, so a couple links here. So there's the style guideline documents, and I have QR codes for the style guideline, and we've just posted an FAQ that contains some background and design rationale that might also be interesting. Those are both on the OpenJDK website, and I've included QR codes with those links. And then the formal proposal for this feature is a JDK enhancement proposal. That link is also there. Anyway, if you have further questions, you can contact me on Twitter or on this hashtag. Thank you very much. We have a couple minutes for questions, I think. Yeah, right down here. Just shout it out. I'll repeat it for the recording.
Was there a reason that you didn't replace the verbose integer with var?
Yes, okay. So that's in the style guide. So the question was, is there a reason I didn't replace the primitive int with var? Yeah, it doesn't really buy you much, right? If you say, you can say int count equals 0, or you can say var count equals 0, right? There are actually a bunch of subtleties, which I invite you to read the style guide. It works okay with int, and it's not a problem to do that, because the right-hand side, the numeric literal 0 is an int. But suppose you wanted to initialize a short variable. So you say short s equals 0. Now, that works in Java because there's some stuff that goes on that says, the right-hand side, 0 is an int, but there's no loss of precision converting that into a short. So that is legal and allowed. But if you were to say var s equals 0, then that s variable would no longer be a short, it would be an int. So you have to be very careful because you have to really understand the exact type of literals if you're going to use var with primitives. And in fact, the types of the primitives, the type names are mostly pretty short, so it doesn't buy you that much. Other questions? Yes, in the back there. Okay, question was about type inference and if you reassign a variable and they both implement the same interface. Now, so there you have to start to think about exactly what type is inferred. So if I said, I had an example, var list equals new array list. Now, if in that case, the list variable would have type array list. And so if you wanted to assign a different type of list to it, like a copy on write array list. I'm trying to avoid saying linked list. If you wanted to assign a copy on write array list to that, then that would not work because a copy on write array list is not an array list. And so there's no magic going on that says, oh, we're going to pick the most common interface, a common super interface. No. Look at the right-hand side, and it just uses that exact type. So in that case, if you did have a variable that was switching between different list implementations, use an explicit type. Probably. I think we'll move on to one more question. I'll be around afterwards. I think there was another question over here. Yes?
Do you or did you give any consideration to how this might be confusing to people that are just starting out learning Java, aren't really knowing about good style, and you can write a method whose name has nothing to do with what it returns or anything inside of it, and it can be a serious source of confusion?
Yeah, so the question was about did we consider how this might impact people who are just beginning Java programming or programming in general? I'm not sure which is more specific. But yeah, we do think about that issue a lot. And I think we do have some contacts in, there's some instructors who teach beginning programming, and I think we're relying on them to introduce these concepts at the appropriate time. And so I would say that we would recommend that they start off using explicit types. Once the student has understood the concept of types, then we can say, okay, you don't have to write that all out, then use var. But that's kind of a later lesson. All right, we're out of time now. Thank you very much.